The real trick to reducing the existence of errors in a spreadsheet is to make sure that from the very start you're considering how errors happen and building in such a way to avoid these errors. The fundamental of good spreadsheet design and enforcing good spreadsheet design will help reduce these errors. And the basic concepts associated with good spreadsheet design are: you must design consistently and make sure that you're aware of what you do and others can see clearly what you're doing. You must separate where inputs can be included, where the calculations happen, and where the outputs or reports are situated. And you must make sure of the integrity of the calculations, not only making sure that they are correct, but clearly showing any users or yourself that they are correct. By using these basic concepts, the spreadsheet you build will have an aspect and it'll be simple to look at. It'll be easier to understand, it'll be easier to review, and it'll be significantly easier to rely on. With regards to consistency, by being consistent in your design process, you eliminate some common errors. So for example, consistency involves cells should contain either data or formula, preferably never both. So in the example down here, you've got two ways of calculating the VAT on a sales price. The wrong way is in the VAT to actually hard code the VAT percentage in. So here, multiplying by 0.14, although perhaps correct at the current stage, will add difficulty later. Spreadsheets do get used again and again, and to actually find all the references to 0.14 when it's discovered that the VAT rate is now 15%, 16%, will be extremely difficult. The better way to do it is you know that you've got an input, a VAT rate, that will affect a number of calculations. Set up an input cell, color it to show it's an input cell, and refer all formulas to that cell. Then if the VAT rate changes, it's just a matter of changing one cell and you know your model will correctly adapt all the calculations. The other important aspect is to make sure that the look and the feel of your workbook is exactly the same. So if in one sheet of your workbook you use a column for one time period, try and make all the sheets in that workbook that same column the same time period. Similarly with rows, if you have one row, try and make it one formula and copy that formula all the way across. From your experience with maps, I'm sure you can imagine the benefit this will have and the ease with which you'll be able to review a model where there's one formula that goes all the way across instead of having different formulas built to handle different situations through the row. Just to emphasize the need for workbooks to look and feel the same, what we've got here is a simple spreadsheet with a summary section, sales, cost of sales, gross profit. And there's a sales summary where there's a unit sold times price and a cost of sales area. And what you can see is in column C is year 1, column D is year 2. And you'll see that on the sales, C is year 1, D is year 2, and similarly with cost of sales. Now although it's not a perfect way of doing it, you'll see that it makes it a lot easier to understand where the formulas are coming from. So if we click on the sales formula, we'll see that it goes to the sales sheet and uses C2 and C3. Now obviously there can still be an error in here, but at least if you've built it in this way, you know that column C is referring to year 1 on all your sheets. Now for example, if we look at this cell here, we'll see that this is taking the cost from the cost of sales sheet, it's taking column F, and we are in column F, we're happy with that, times column F, and then it's adding column E. Now it's not the ideal way to find errors, but it does make it significantly easier, and you're quite likely to actually spot some sort of inconsistency by building your models in a consistent and clear way. Getting back to other consistency ideas, it is highly recommended that you make use of Excel's inbuilt functions. In the function wizard there are a number of useful functions, and what often happens is people don't look through what Excel can do and they try and generate their own functions. And then they use different techniques, different methods. Excel has built a number of useful functions in it, and if you continue to use your functions, Not only will it be easier to understand for other users who use functions, but it'll also make it easier for you to make sure that your spreadsheet doesn't contain any human generated errors. Another area is where you've got very complex formula. Often you click on a cell and there's a triple nested if function, very complex, lots of brackets, lots of calculations. It is often easier just to split it up over a number of rows or columns, just to make it fairly easy for the person to actually understand what is going on. To emphasize this, here's that same spreadsheet again. If you look at the cost of sales formula, you'll see that it makes reference to a number of cells, and the calculation is actually happening at the summary page. So in order to actually track down if this is correct, you can use your auditing toolbar, but you now need to know that you're taking cost of sales C2, which is that one, which you're happy with. Then you need to come back here, it's multiplied by that one there, and obviously you're happy with that. And so it is a bit of a process. You can use Spreadsheet Professional's Formula Tracer, but you might not always have Spreadsheet Professional on the machines that look at it, and other people might not have it. So why not make it a bit easier to understand? Do the calculations in the area. So you'll see here's total variable costs. It is a calculation multiplying that by that. That's the fixed labor cost. There's your total. And now in the summary sheet, instead of having this formula here, you can just say equals, go to year 1, enter, and then you can just copy and paste it. Now instead of having a complex formula, you can look here, see that it's referring to the correct year. You'll know it's copied across correctly, and then your only concern is to go to the cost of sales and just follow this back and make sure that you're happy that this is calculating correctly. And just by splitting the calculation over a couple more rows, it's a lot easier to understand. And it's important to remember that a lot of people look at spreadsheets actually on a printout, and therefore this will be significantly easier to understand than some complex calculation built into one area. Other areas with regards to consistency. It's useful to decide upfront on the format of the data you're using. When you're designing a model, decide, are you using whole numbers, are you going to use thousands, are you going to have millions? A lot of problems are caused because it's not always clear what units are being used, and where you perhaps should be multiplying two whole numbers together, sometimes you're multiplying the millions figure with the whole number. Make sure you know what units you're working in. Is everyone working in kilograms or pounds, kilometers, miles? This causes a lot of problems because everyone works with what they are comfortable with. It's not always clear on a spreadsheet, so even if you have to just make it perfectly clear, show what units are being used. Try also be consistent with negative numbers. I like to show a negative as a negative. So where I have a cost of sales number, it will generally be actually a negative, and any calculations that need to be used on that will actually be an addition. The reason for this is, again, focused very much on printouts. It's not always clear on a printout whether you should be adding or subtracting something. Maybe in some areas like cost of sales it's obvious, but what about interest? Is it interest received or interest paid? So what I like to do is clearly show where the negative numbers are and where the positive numbers are. The other concept with regard to good spreadsheet design is separating the various areas of a spreadsheet. What this involves is to group like information with itself. So you can put all your inputs together. Now, depending on the size of the spreadsheet, what this might mean is that all the inputs would be on one sheet, and all the calculations on a separate sheet, and all the reports on a third sheet. Alternatively, if it's a fairly small spreadsheet, use the top section for inputs, put the calculations below that, and then have a summary report which brings together and shows what you're trying to achieve on your spreadsheet. If possible, you can use colors as well, because it's not always that easy to separate out where inputs and calculations end. Be very specific and decide, and upfront create a legend saying, for example, I like to use light blue is the color for where my inputs are. Just a couple of other things. Fill in the whole cell and not only the characters, and we'll get onto that a little bit. Preferably use light colors, because when you print out a spreadsheet, if you use darker colors, you can actually sometimes not see the number underneath. So use a light blue, light yellow, etc. And where you can, use protection. Protect cells that you don't want to be overwritten. You don't have to put an actual password on. It's just a warning so you don't accidentally overwrite it. To go back to the idea of coloring whole cells and not the only the characters or the numbers, this is the way I like to do it, to have the whole number colored in. Some people make use of this method where the actual numbers or characters are in a color. The problem I have with that is if, for whatever reason, this isn't there and we delete it, it's not always clear that you need to put a number in there, and only the person who works regularly with the model would actually know that the fixed labor costs need a number. So I find this is more explicit and it's more likely to actually result in a clean model with all the inputs entered. Getting on to the third concept, integrity of calculations is important. So not only should the model be correct, but it should indicate to the user or someone reading it on a piece of paper that it is correct. As mentioned previously, it's often senior people in the organization review models based on a paper base, or it's printed out in a report. When you build a model, it's useful to keep that in mind, simply because they cannot go into the formula and see what you've done. So explicitly show them what has happened. Use error checks where at all possible, and build them in so that it clearly states on the spreadsheet whether it's okay or not. You must cross-cast matrices just to make sure that the calculations going down are the same as calculations going across. You'll be surprised at how many errors can be picked up this way. If you've got a balance sheet, prove the balance sheet. If you've got a cash flow statement, compare it to the balance sheet. Try not use balancing numbers. If you've got building a particular spreadsheet and there are general manual checks you do to assess the reasonableness and see if it works, build them into the spreadsheet. It's a lot easier to build it into the spreadsheet than to have to redo it manually each time. And use a data validation tool in Excel to control some of the inputs that go into it. Other design tips. As shown, multiple workbooks can cause problems, and I recommend you avoid them where at all possible. Develop a good naming convention for version control. Whether you like it or not, there will be multiple versions of a spreadsheet and it changes regularly. It's useful to keep a backup of where you've been, but be specific about what the name of the current version is. Include a date or time if that's relevant. Make the input section as similar to any paper-based inputs as possible. So if you normally used to capture information on a paper form, make it similar so people don't get confused. Don't make radical changes to a process. If the formula is complex, split it over a number of rows or columns. And use the protection feature in Excel to reduce the risks of accidental deletion of cells. And just another thing, it's always useful to plan up front what you're trying to do. And I recommend you literally just put a little drawing on a piece of paper. And I recommend you work with something like this. You know you're going to always need inputs in a spreadsheet. You're going to have to do a few calculations and you need a few outputs. Once you get to that stage, work backwards. What are you trying to achieve? What are the outputs? Just list the reports you want to do. Then think through the reports you want to develop and work out what calculations are actually required to develop those reports and list the calculations. And then depending on what calculations you need, you might need some other information and inputs. And you can quickly list those inputs. If you just take 5 minutes doing this, you'll be amazed at how much more structure your spreadsheet has. And as you can see, the separation is set out for you. Input, calculation, output. As you use it more and more, you'll see it'll get bigger and bigger, and your mindset will be built more in this way. If you're going to use a complex if function, again, draw a quick picture. Specify the requirements and write down what happens if it's true and what happens if it's false. In this case, if it's false, there's another if function sitting there. Write the condition, what happens if it's true, what happens if it's false. Once you've got the drawing set up, it's a lot easier to actually code the formula and know where the brackets start and stop.